I was sitting in the porch of the house at a trading station of Vanavara at 7 a.m. and looking towards the north. Suddenly the sky appeared like it was split in two. High above the forest, the whole northern sky appeared to be completely covered with blazing fire. At that moment I felt a great wave of heat as if my shirt had caught fire. After a minute, there was a loud bang in the sky, and I could hear a mighty crash. Subsequently, I was fiercely thrown to the ground about 5 to 6 meters away from the house, and for a minute or two I lost my consciousness. That's how the Tunguska event felt 40 miles from ground zero. Farmer Sergei Semyenov is only one of the few people who witnessed the Tunguska event and survived. At the time of explosion, he was having a breakfast in trade station of Vanavara, located approximately 40 miles from the epicenter. Closest seismograph installed in Irkutsk, 600 miles from the epicenter, recorded strong vibrations lasting more than 60 minutes. Sound waves caused by the event encircled the planet multiple times. More than 800 kilometers away, in the city of Kansk, the noise was so loud that a train engineer stopped his train, thinking that one of the freight cars had exploded. Later, black rain falls over central Siberia, and in Europe the setting sun colors the sky in an oddly deep pink. In London, citizens call the police. They think a major fire has broken out. Over the following 3 nights, it remains so bright over the European continent and parts of Asia that in St. Andrews, Scotland, for example, golfers completed their rounds at 3 in the morning without additional lightning. Hundreds of kilometers away, the Tunguska event can be heard, its halo seen, and its shock felt. It is unclear what really happened at that time. The only thing we know for sure is that a huge explosion happened, with a suspected explosive force of between 3 and 30 megatons of TNT, or roughly 1,000 times more powerful than the Hiroshima bomb. It devastated an area of more than 2,000 square kilometers. But what exactly happened on the Tunguska River in 1908? Since only Siberian newspapers reported on the explosion in the Tunguska region, neither in Western Europe nor in St. Petersburg, the capital of the Tsarist Empire, did anyone learn anything about the possible connection between the earthquakes and the bright nights and the fireball over the taiga. 19 years later, in April 1927, the first geoscientist entered the area of the catastrophe, Leonid Alexeyevich Kulik. In 1921, Kulik got his hands on an old newspaper from Siberia. For him, there is no doubt. It must have been a meteorite. A chunk from space, the fragment of an asteroid. Asteroids are small celestial bodies made of metal-bearing rock. Their diameter can be a few meters, but also several hundred kilometers. Most asteroids orbit the Sun in a great track between the orbits of Mars and Jupiter. If they collide, they can be thrown off course and enter the Earth's atmosphere as meteorites. With the newspaper report in his luggage, Kulik traveled 4,800 kilometers on the Trans-Siberian Railway to Kansk in East Siberia, where he interviewed dozens of witnesses without any notable success. He also did not find any meteorite debris in the landscape. While researching the archives in Siberian newspapers, the researcher came across numerous other reports about the natural disaster. Contemporary witnesses heard up to 14 cannon thunder. Most, however, have observed a huge ball of fire that shot horizontally across the sky. Analyzing the testimonies, Kulik realizes that the meteorite must have struck further north, somewhere on the stony Tunguska River. Full of optimism, he returns to the capital to collect money for an expedition. Despite initial skepticism, the Soviet Academy approved the expedition. At the end of March 1927, Kulik and his assistant reached the Vanavara trading station, a handful of houses, snowy trails, and a few storage sheds. The scientist learns that reindeer herders from the semi-nomadic Tungus people were closest to the center of the explosion. At first, the locals were reluctant to tell Kulik about the dreadful June morning. The Tungus believe that the natural disaster was a punishment from their fire god Ogdi, and it will rage again if someone ventures into the disaster area. Nevertheless, Kulik managed to win a reindeer herder as a guide. For days, the men trudged downstream through the wilderness along the stony Tunguska. Far and wide, no meteorite crater. But on April 13th, Kulik stands in amazement on a slope. Hundreds of mighty larches and birches lie at his feet, mowed down like blades of grass. Their crowns point south. The researchers speculate that a pressure wave triggered by the meteorite impact must have cut down the trees. 3 months later, and now suffering from scurvy, Kulik arrived at ground zero, where he found the trees there standing upright, but their limbs and bark had been stripped away. They looked like a forest of telephone poles. Those trees acted as markers, pointing directly away from the blast's epicenter. Such debranching requires fast-moving shockwaves that break off a tree's branches before the branches can transfer the impact momentum to the tree's stem. 37 years after the Tunguska blast, branchless trees would be found at the site of another massive explosion. Hiroshima, Japan. As it will later turn out, the shockwave knocked down more than 80 million trees in an area of 2,150 square kilometers. It is thanks to the cold climate of central Siberia and the far lower number of microorganisms compared to the temperate latitudes that the uprooted trees are hardly weathered and in the spring of 1927 look almost as they did immediately after the explosion. The researcher recognizes burn marks on the trunks. As the meteorite entered Earth's atmosphere, friction heated the denser layers of air, he suspects. What amazes Kulik even more, not even here in the presumed epicenter can he make out a crater. He only notices a few hollows in the ground, a few meters deep and 10 to 50 meters in diameter. Half fragments of the celestial body sunk here. The scientist believes that the riddle is about to be solved, but the food supplies are running out, and he had to abandon the expedition. Leonid Kulik's return to Leningrad in the autumn of 1927, although he did not bring an ounce of precious metal from space, was a triumph. His report on the huge destroyed forest not only impressed the experts from the Soviet Academy of Sciences, but also the New York Times and the Times in London are now writing about the bombed area. The Academy promptly received records from many countries of strong seismic pressure waves from 1908, for which no one had previously had an explanation. Kulik knows how to show his audience the dimensions of the Siberian catastrophe. If the meteorite had exploded in the atmosphere just under 5 hours later, St. Petersburg, which was the capital of Russia at that time, would have been completely destroyed because of the Earth's rotation, he says. A scenario that electrifies the audience just as much as the prospect of finding the meteorite is that the meteorite's metal could be worth up to $200 million. Kulik's second Tunguska expedition remained unsuccessful. On a third trip in February 1929, he penetrated to depths up to 34 meters with hand drills without encountering any chunks from space. With graying hair, depressed and emaciated, Kulik returns to Moscow. There, doubters attack him, because rock is not massive enough to withstand the high air resistance at an altitude of 10 to 15 kilometers. A meteor made of rock would have left fragments in the ground and formed a crater. So far, however, nothing has been found in the Tunguska area. In 1934, Soviet astronomers publicly claimed for the first time that in June 1908 it was not a meteorite that hit Siberia, but a comet. Comets, like asteroids, originated more than 4 billion years ago, when our solar system was born out of a swirling, hot cloud of gas and dust. They consist mostly of water ice and frozen gases like carbon dioxide and ammonia, which is why they are also called dirty snowballs. As a comet approaches the sun, its ice evaporates, forming a shell of gas that is blown out by the solar wind into a 1,000,000-kilometer-long tail that glows brightly in the sky. This effect could explain the observations of many eyewitnesses to the Tunguska explosion, who report a ball of fire flying horizontally across the sky for a long time. And since the celestial body had already burned up in the air, no fragments could be found. But where did the burn marks on the trees come from? Leonid Kulik sticks to his meteorite thesis. In the late 1930s, he photographs a devastated area from the air. It is shaped like a butterfly, and the epicenter of the explosion must have been near its head. Kulik doesn't find out more. When he died of typhus in a Wehrmacht prisoner war camp in April 1942, at the age of 58, the mystery of Tunguska was still unsolved. Alternative theories are becoming all the more popular, no matter how bizarre they may be. For example, the Tunguska disaster was a nuclear explosion. After the atomic bomb was dropped in Hiroshima in August 1945, the science fiction author Alexander Kazantsev from Kazakhstan visits the Japanese city. In Hiroshima, he noticed similarities to the devastated areas on the stony Tunguska. In Japan, too, there were upright trees without any branches a few hundred meters from the epicenter of the explosion. The buildings in the area, however, were knocked down by a blast wave, like the forest in Tunguska. Even the science fiction author doesn't want to believe in an atomic bomb test by the Russians as early as 1908, but in guests from space. A nuclear-powered UFO exploded and crashed over central Siberia. The extraterrestrials were looking for water and therefore headed for Baikal, the largest freshwater lake on Earth, 800 kilometers from the site of the explosion. As hard as it may sound to believe, at the end of the 1950s, scientists from Tomsk detected increased radioactivity in soil samples from the Tunguska region. Equally striking, radioactive cesium-137 is highly concentrated in the annual rings of the Tunguska trees from 1908 and 1909. Numerous Soviet scientists take up Kazantsev's theses of the crashed nuclear-powered UFO. In June 1959, Felix Siegel, professor at the renowned Moscow Aeronautics Institute, wrote that it was the only realistic depiction at the present time. In 1973, American physicists attempted an explanation for the first time. In the science magazine Nature, they write that a black hole triggered the explosion, a burned-up star from space. Their theory: on June 30th, 1908, a black hole shot through the atmosphere over central Siberia and bored into the Earth in the Tunguska region. On its way, it heated the air to more than 10,000 degrees Celsius, triggered an explosion, and pierced the planet like a projectile. 15 minutes later, it re-emerged through the North Atlantic. Due to the special physical properties of black holes, no crater was formed when it hit the taiga floor. So Kulik and his team could have looked for it forever. What the proponents of this thesis did not consider: shooting a black hole out of the ocean should have triggered a massive tsunami. However, no archive in the world contains reports of such a tidal wave in June 1908. This fact gave Wolfgang Kund, professor of astrophysics at the University of Bonn, an interesting thought in the late 1990s. The fact that almost all experts are still sticking to the impact theory is starting to seem ridiculous, he says. For Kund, the pattern of the felled trees traces 5 epicenters, and according to this, the celestial body must have hit the Earth in 5 places. But nowhere can corresponding extraterrestrial material be found. Kund, of all people a renowned explorer of the starry sky, suspects that the trigger for the explosion did not come from space. He believes in a volcano-like natural gas eruption. Volcanic eruptions can take very different courses. Extremely vicious magma leads to explosive eruptions. In the case of low-viscosity magma, on the other hand, the natural gas often separates before the magma reaches the Earth's surface and forms a cloud. The latter happened with high probability in June 1908 in central Siberia. Kund's scenario: 10 million tons of methane as well as hydrogen and helium flowed under high pressure through cracks in the taiga soil into the air, expanded, and about 80% of the natural gas shot 200 kilometers into the atmosphere at supersonic speed. The gas pushed the surrounding air masses outwards as a massive storm field, mixed with oxygen at the edges, and ignited. Kund suspects that the at least 14 cannon thunders that contemporary witnesses heard before the sky began to burn were probably explosion noises. Kunt also believes that he can explain the light nights in Europe and parts of Asia. Water vapor has risen about 700 kilometers into the atmosphere, where clouds otherwise never form, and has frozen into snow crystals. These scattered the sunlight into areas where it was already night, similar to the eruption of the Krakatau volcano in Indonesia in August 1883, which also produced a lot of water vapor. Therefore, between Stockholm and Tashkent, between Ireland and the Urals, people experienced 4 consecutive bright nights that went down in history as the so-called White Nights. Wolfgang Kunt's claims sound conclusive, and yet they have a catch. The majority of eyewitnesses did not see flames or pillars of fire, but a gigantic ball of fire that shot across the sky like a comet. Probably mistaken memories, replies the astrophysics professor. After all, most contemporary witnesses were only questioned more than 10 years after the explosion. A research team led by astrophysicist Vladimir Paryev from the Lebedev Institute of the Russian Academy of Sciences in Moscow has taken a closer look at the inconsistencies associated with the Tunguska event. No black hole, no UFO, no rock, no comet of ice. So what remains? Iron is the solution to the riddle. At least it could be. An object from space that is not made of ice or rock, but made of solid iron would meet the requirements of the Tunguska phenomenon. Meteorites that consist mainly of iron have a higher density, therefore only parts of the surface are melted. The idea: a heavy chunk of iron, larger than 100 meters in diameter, wouldn't burst in the atmosphere, shatter into 1,000 pieces, or leave debris on the ground. Moreover, it wouldn't leave an impact crater at all, because it would only have stopped by Earth on a flying visit, a grazing shot from space. Vladimir Paryev explains it like this. This iron object drove an enormously powerful shockwave as it flew through the atmosphere, faster than sound and faster than a pistol bullet. This shockwave was so strong that it destroyed the trees in Siberia's forests over an area of 2,000 square kilometers. If the Tunguska space object consisted of iron, it could explain why there are no iron droplets at the epicenter. They simply couldn't form because of the speed of the space body in the atmosphere, which means that a body's surface temperature exceeded several thousands of degrees Celsius. Any mass loss would be through the sublimation of individual iron atoms, which would look exactly like normal terrestrial oxides on the ground. The iron meteorite traveled at a phenomenal 20 kilometers per second speed, hitting the atmosphere at a shallow angle, somewhere between 9 and 12 degrees, before exiting into the outer space, shredding about half of its over 30 million tons weight on the way. The sonic boom in the air, the burned and downed trees on the ground, all of this could be the result of an iron meteorite flying by, only about 10 to 15 kilometers up. But it gets even better. This chunk of iron moved away from the Earth again and is now orbiting the Sun. And that means that it could approach and hit Earth again at any time. And the possibility of this scenario can be calculated. Once every 50,000 years. A deceptive certainty. We don't know when it will happen again. Maybe next year. It may take another 1,000 years or 100,000 years. It is all just statistical estimate. However, a collision still seems unlikely given the size of the solar system and estimates on the quantity of near-Earth objects. But there's also little confidence that we would see one coming. In April 2018, for instance, an undetected asteroid possibly as wide as 360 feet passed by the planet at a distance closer than the Moon. Although the results sound convincing, the researchers admit that their work still leaves some unanswered questions. It is not entirely clear whether their assumptions about the formation of a shockwave are correct. However, comparisons with the Chelyabinsk meteor of February 15, 2013 would speak in favor of this. The scope of uncertainty surrounding the Tunguska event covers many aspects of it, but all are confined to a narrow range of possibilities. Thank you for watching.